Hello everybody. I've been working on the radio for our epilepsy dog. Inside this radio there is a button you push and hold for 3 seconds. If you do that, it sends an alarm to the other radios. Now, I tried this with an earphone jack design, which was a mechanical switch. It kept breaking on me. The dog running around bumping into things would break the earphone jack off. So I tried to switch it to a magnetic reed switch. The problem with that is that the contact is normally open and the reed switches that I need to use are normally closed. So when I hook the reed switch up, when the magnet's in place, the alarm goes off. When the magnet is taken away, it does not. We need it to work the opposite. So a friend of mine told me about this 7404 microchip. It is a signal inverter, and what I've done is run the wire from that button to leg number 1. That's the blue wire you see on the left. That's actually on leg number 1A or leg 2 of this chip. What we basically have is the magnetic reed switch is wired into leg 1 and over to ground. That's the white wire that comes around to this reed switch. Now, this reed switch, when in place, sends a ground signal to leg 1 of the IC, which causes the 1B or leg number 2 of the chip to be positive. When the reed switch is removed, that's going to change that to a non-negative signal, and that's going to allow this to flip-flop, and it will make contact with ground. So when that happens, after 3 seconds, if it's wired right, the radio will go into alert mode. See the red button here? Alright, so the chip is being powered by an almost dead 9-volt battery, which will not be part of the completed circuit. This is normally requiring anywhere from 5 to 7 volts. I am going to pull these 2 lugs, or this voltage off of this 9-volt battery, will be replaced by the 5 volts provided by just the battery within the transceiver here. So, very simple design. My buddy Jay up in Philadelphia, he's an electronics guru. He helped me with this. So now I'm going to remove the reed switch, if I can figure out how to do it without dropping everything. And we're going to see, hopefully, the light on the radio come on, and after 3 seconds we should get an alarm. So here goes the reed switch. There we go. See the radios come on. Okay, let me turn this off. And we'll place the reed switch back. Circuit's back intact. And we'll turn the radio back on. So, what we have is a normally open contact that needs to be closed, and I think what happens is that it sends 5 volts off of the chip inside the radio to ground, and when that 5 volts goes to ground, that causes this emergency transmitter built into the radio to go off after 3 seconds of contact. So again, we've got the 7404 chip. The magnetic reed switch is supplying a ground while the magnet's in place to lead 1. That's causing lead 2 to stay positive. When I remove the magnetic switch, lead 2 switches from positive to negative. When that occurs, the radio senses that and it goes off. Now this modification has been done for somebody with epilepsy. We've trained their dog to pull a strap. The strap will be connected to this magnet over here. When the magnet is pulled away from the other part of it, the reed switch, the alarm goes off and lets her mom know that she is having a seizure. So the dog is an intricate part of her life now. Thanks.